All right, today, instead of saying the cosine of 30 degrees equals square root of 3 over 2, we're going to work backwards and find the cosine of what equals square root of 3 over 2. Well, to find that, what needs to be equal to the inverse cosine of square root of 3 over 2, right? And what works out to be 30 degrees. Are you all right with that? Okay. Get out your unit circles once. You need a unit circle. Well, let me see if I have a unit circle for you. Because I don't know where my extra unit circles are. But I'll see if I can find an extra unit circle. All right, Mr. Brown, walk over to Mrs. Olson's room and grab it out of the printer. Okay. So, on our unit circle here, how many places do we see the cosine equal to square root of 3 over 2? Just one? We see two. Oh no, that puts us in a conundrum. Which should be the correct answer? Should it just be 30 degrees? Or should it be 330 degrees? Because that also works. And so the answer is, some of you would say, well, 30 degrees comes up on my calculator when I hit it. So that should be the answer. Okay. Well, knowing that, we look at our unit circle and we say, hey, we need to make up a rule for this. Okay, so here's our rule. When you deal with cosine, you're just using this part of the unit circle. From 0 to 180 degrees. When you're dealing with inverse cosine, I mean. Inverse cosine, it's anywhere from 0 to 180 degrees. Where things get a little crazier is when we're dealing with sines and tangents. When you're dealing with sine and tangent, where is the sine equal to 1/2? Where is the sine equal to 1/2? What's one place? 30 degrees. What's the other place? 150. So we can't use the same place as cosine because they have matching answers for sine. So what we do for sine is we start here. We go all the way around to here. So instead of calling it 90 degrees to 270 degrees or 270 degrees to 90 degrees, we call it, for sine and for tangent, inverse sine and inverse tangent, that is, we go from negative 90 degrees to 90 degrees. For inverse cosine, we go from 0 degrees to 180 degrees. And their corresponding radian measurement. Okay? So, this is important to know. Now, what do you think we do for cosecant? Probably the same as which trig function? What's cosecant the reciprocal of? Sine. So cosecant would be with sine. So cosecant would be one of the top two. And what about cotangent? With tangent. So it's one of the top two. What about secant? With cosine. So it's that one. So let's look at some problems. What's the ratio for sine equal to? What's the ratio for sine equal to? Opposite over hypotenuse, right? Okay. What's the ratio for tangent? Opposite over adjacent. So you need to know those things. Where is the cosine equal to square root of 3 over 2? From your unit circle, it is 30 degrees. Where is the cosine equal to 1 at? Where is the cosine equal to 1 at? How many degrees? 0 degrees. At 0 degrees, cosine is equal to 1. Where's the tangent equal to 1? Not 30. Where's tangent equal to 1? Not 90. Not 0. Somewhere in between negative 90 degrees and 90 degrees, tangent is equal to 1. Look at your unit circle. 45. Why would it be 45 degrees? Sine? Tangent is sine over cosine, which is y over x. Where are y and x the same thing? Because y and x are the same thing, it equals 1. It's at 45 degrees. Okay? Where's sine equal to 0 at? Where's sine equal to 0 at? 0 degrees. Now you have to evaluate with a calculator. If you don't have a calculator, you're up a stream without a paddle. Okay? And you're just floating downstream with nothing. So, what's the inverse cosine of 5/7? Round to the nearest tenth. How many degrees is that? 44.4 degrees? If you didn't get that answer on your calculator, you might be in radian mode. So you might have to go to mode and change it to degrees. Understand what mode your calculator is in at all times. Because sometimes you need to be in radian mode, sometimes you need to be in degree mode. This one, we're still in degrees. The inverse tangent of 0.5 or 5.68. How many degrees is that? Inverse tangent of 5.68. 80.0? Sounds good to me. If the sine of alpha is 0.2329, what would you punch on your calculator? You would hit second sine 0.2329. Inverse sine at 0.2329. What do you get? 13.5. Okay. Inverse tangent of 4/9. Inverse tangent of 4/9. Point 24.0. Okay. So hopefully you can do that. Now, the 6 trig functions. What do I have to do first before I can start figuring out my 6 trig functions? Figure out my hypotenuse. How do I figure out my hypotenuse? Use the what? Pythagorean theorem. C squared equals A squared plus B squared. You get the square root of 37. So what's the sign of alpha? Sine is what over what? Opposite over hypotenuse. It's 1 over square root of 37. Can we leave it like that? No. We have to multiply top and bottom by square root of 37. So it's square root of 37 over 37. What's cosine of alpha? Adjacent over hypotenuse. 6 over square root of 37. Can't leave square root of 37 on the bottom. So it's 6 square root of 37 over 37. Tangent. Opposite over adjacent, 1/6. Secant. Square root of 37 over... No! 6. Secant is the inverse of cosine, not the inverse of sine. Don't just think, well, since that's first, this goes with this. No. No, 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 no. Make sure you read what you're supposed to be doing. What's the cosecant of alpha? Put your mask up. Square root of 37 over 1, which is just square root of 37. What's cotangent of alpha? 6 over 1, which is just 6. Okay? Now, this one is a little different. You think, oh, that looks like the last one. No, it's a little different. The short leg is 6. The long leg is 8. What's your hypotenuse going to be? 10. Pythagorean theorem. 36 plus 64 is 100. Square root of 100 is 10. So, sine of alpha. Well, alpha's up here. What's its opposite side? 8. What's its hypotenuse? 10. So it's 4/5. What's the cosine of alpha? 6/10, which is 3/5. What's the tangent of alpha? 8/6, which is 4/3. What's the sine of beta? What's the sine of beta? 6/10, which is 3/5. The sine of beta is the same as the cosine of alpha. What's the cosine of beta? 8/10, which is 4/5, which is the same as the sine of alpha. Okay? What's the tangent of beta? 3/4. Okay? I think you can do that one by yourself. I think you can do that one by yourself. Okay, solving a triangle. Solving a triangle. What you have to do is you draw out a triangle. The right angle is always opposite of C. C and the right angle are always opposite. So if they tell us C is 22, you put a 22 there. Alpha, doesn't matter where you put alpha, here or here, but once you name it, then you leave it. That's 15 degrees. So beta must be this one. Gamma is this one. Okay, if this is 15 degrees, if we want to figure out what angle beta is, it's whatever's left in the triangle. How many degrees are left for beta? 75 degrees. So this is 75. How do we find A? Well, A is opposite of alpha. B is opposite of beta. Okay? So A, how do I figure out A? Well, if it's opposite and we know the hypotenuse, we must use opposite and hypotenuse is? Opposite and hypotenuse is sine. So the sine of 15 degrees equals the opposite side A over the hypotenuse of 22. How do I get A alone? Multiply by 22. What's 22 times the sine of 15? Round to one decimal place, 5.7 equals A. Okay, how do we figure out B? Well, B is what to the 15-degree angle? Adjacent, so it must be cosine. So the cosine of 15 degrees equals B over 22. What do I do to each side? Multiply by 22. 22 times cosine of 15, what does B equal to? All right, from the top of a lighthouse, the angle of depression to a small boat. So here's the lighthouse. There's a horizontal line. Here's the angle of depression down to a small boat. Okay, the angle of depression is 39.0866 degrees. The lighthouse is 69 feet high. How far is the base of the lighthouse away from the boat? Oh, how far is X? A ways. A ways. Yeah. Good answer. Yeah, Math Excel won't give you credit for that one. All right. So, hey, I made a triangle here. Look at that. A right triangle. But I don't have any angles in it, do I? But I got to find an angle inside there because I know this side is 69. What angle might I know? The top angle? I might know that one because that would be 90 minus 39.0866, right? Or could I know this one too? This is a horizontal line. This is a horizontal line. These lines are parallel. So if this is 39.0866, this angle down here is 39.0866. The angle of elevation is equal to the angle of depression. Why? Because they are alternate interior angles from the world of geometry. Alternate interior angles. All right. So if I know this angle, if I know this side, and I want this side, what am I doing? Sine, cosine, tangent. What trig function? Tangent. The tangent of 39.0866 equals 69 over x. Ooh, that gives me a variable in my denominator. Do I want to solve that? Not really. So what's this angle up here? If this one's 39.0866, what's this angle up here? 50.9134. What's the tangent of 50.9134? What's that tangent going to be? What's that tangent? What fraction is that going to be equal to? X over 69. Do you see how switching angles makes life a little easier? Because to solve this one, how do we get x alone? Multiply by 69. Take 69 times the tangent of that. What do we get? 69 times tangent of 50.9134. That boat, round to the nearest foot, is 85 feet away from the bottom of the lighthouse. Not very far, no. Okay. If you watch enough TikToks, you'll see like trucks hitting the top of bridges and things like that, you know. If you watch the right TikToks, I guess. Okay. So it looks like this vehicle might hit this walking bridge if they're not really super careful, especially if they're over there a little further. Then they're gonna have problems. Then they're gonna have car damage, or they'll have bridge damage too. Okay. So they're not asking where the vehicle will run into the bridge. They're asking for what is the height of the bridge at its maximum. Well, we make a right triangle here. So here's our right triangle. We know 7.35 is there. What's the base of this triangle going to be? Half of whatever that number is. Well, that number is 340. Half of that is 170. If I want to know the height, what trig function would I use? Tangent. The tangent of 7.35 degrees equals h over 170. How do we get h alone? Multiply by 170. So h equals, what's 170 times the tangent of 7.35? One seventy times the tangent of 7.35. So the height of that bridge is 21.9 feet. That's not a very tall bridge, even in the way center. There's no way a bus would be fitting under that bridge. Unless well, maybe a bus would. 20 feet, yeah. Bus probably would, yeah. But still, the bus wouldn't fit over this part of the bridge. Let's just say that. Okay. All right. That's about it for this lesson. I'll put it out there for you.